what applies to, you know, like to general, like projects that have some machine learning component. And here you can see different topics that we will discuss. How to frame a problem as a machine learning task, how to prioritize some ideas that you have, how to collect, transform data, how to evaluate ideas, because usually you have a lot of ideas, and then, you know, basically how to prioritize them and then see which one you will focus on first, right? And continue. And then also how to move to production. Another motivation for me is to promote Informatica. Of course, I mean, there is a brand logo and all that stuff. And also, I would like to bring you closer what we are doing in Informatica, because before I joined Informatica, I haven't had heard about Informatica. And it's an interesting story how I started working in Informatica. Basically, my wife is an architect, and at the time she was looking for a job. So she put it, you know, like in LinkedIn and Indeed, you can set alerts, right? When the new job is there. And she put it like architect, architecture, and that stuff. And the job posting from Informatica came that was mentioning some of those keywords, and she forwarded to me. So I was like, okay, I mean, the job seemed interesting, but I never heard about, you know, like Informatica. So as I went through and I learned a little bit more about Informatica, it started to be more interesting for me. So I mean, the point is maybe, you know, you can find some fit or something that is interesting for you as well. So this is also one of my motivations for this talk. Okay, so this is the project that I'm going to talk about is about the recommender system, the transformation recommendation system. And before I start talking about the transformation recommendations, I would like to give you a brief introduction about mappings and ETL procedures. This is one of the products that we have at Informatica. So my assumption is, my guess is basically that not all people are familiar with ETL procedures and mappings. So basically, what are ETL procedures? It stands for extract, transform, and load, right? And these procedures are used for data integration, right? You have different data sources in different systems, right? You can have a database, you can have some app like Marketo or Salesforce, you can have some flat CSV files, etc. So there are different, right, sources, and you can, right, use these procedures to basically program, to write a simple program that will load the data, transform it in some way, and then store the data in some other source, right? So let's take an example, right? Let's say we want to see how well we were selling our product over the different geography, right? Or over different demographics, like, right? I mean, where are our customers coming from, how old they are, et cetera, right? Now let's imagine that we have two data systems, right? One system is with the customer data, right? We have customer data in one, let's say, database, and in another one we have our sales data, right? So basically, what we can do, we can connect to one source, right? We can connect to another source, and basically we can do sort on one of those just to have better performances, and then we join, right, those two sources, and then after that we can do different transformations. For instance, we can aggregate, right, these records by, for instance, by the country, right, where the customer is coming from. and then we can generate the report. For instance, well, the simplest one could be a Excel spreadsheet, right? We can generate an Excel spreadsheet with the aggregated results, and we can store that in some on some files share, right, system, or if we want, like, we can store back to some database. So this is like an example of writing a simple ETL procedure, right? I mean, we can do that programmatically, and we can use one of our favorite programming languages and all that stuff. The thing is, I mean, if we're doing that every day and there are a lot of similarities, I mean, it can take us a long time, right? So the long story short, why we are using ETL procedures is basically to make our life easier and to, like, put a couple of these boxes and parameterize them and execute some data integration tasks, right? And there is a lot of abstraction. Basically, within sources, we define just which source we want to use, and we don't care about how we are going to connect and all that stuff, right? So this is a brief introduction about data integration and ETL procedures. And the project that we've been working on is basically we wanted to extend our product called Cloud Data Integration, which is a tool for building those ETL procedures. And before this project, basically our users were using, you can see this is a canvas of the data of the ETL designer. And how they were building ETL procedures was like on the left-hand side here, you can see a list of transformations that you can put basically on the canvas. So users were going through this list, and when they need something, basically they were drag and drop those transformations on the canvas. What we wanted to bring those transformations closer to our users, so they can, like, as they progress building the ETL procedures, basically they have access to the transformations that they can use. So what we did, basically, we introduced this drop-down list, right, where you can, as you build the procedure, basically you can select one of the transformations from a list, and you can use it on your inside of your pipeline, right? So the machine learning part here was actually, like, this list is decently long, right, of the transformations that you can use. And basically, instead of scrolling down through this list, we wanted to predict which transformations are you going to use based on the transformations that you already used on your canvas, right? So to me, this is very similar as when you are coding and programming your function, right? I mean, you probably, all of you, use some programming environment like IntelliJ or PyCharm or Visual Studio or whatever you're using, right? And when you're coding your program, you have that auto completion, right? You start something and then you continue. You can get a list of recommended completions, and instead of typing everything, right, you can progress faster. So the idea here is the same, right? As you're building your ETL procedure, you continue by using some of those suggestions that we provide, that we predict, right, that the user is going to use, and you add to your canvas. If you're interested more about this feature, I put the link to the docs, So you can take a look. And also one notion about ETL procedures in Informatica terminology, we call them mappings. It's historically because, right, I mean, we are mapping something from the source, right, to the target. And so I'll use mainly the term mappings, just not to be confused. Like mappings are right, I mean, it's the same as ETL procedures, where you're connecting your source to a target and on the way you transform your data as you like, right? So to give you a brief overview of the life cycle of machine learning projects, like there are some 5 typical phases when you're developing your project, and you can see in different literature and people are naming it differently, but these are the main things, right? Like first phase is like data acquisition. And this is when you understand the problem that you're solving, you want to get the data and actually figure out what you have, right? How the things are working. And this phase is usually very labor intensive. It takes a lot of time. Like some estimations are 60, 70, 80% of the whole project time you spend, you know, like transforming the data and you know, integrating and looking what's the format and how you need, you know, like to transform data so it can work for you. So this is the data acquisition when you prepare basically your data. And then the next phase is data exploration. And this is the phase where you want to really understand your data, what's there, and get an intuition. So this is like you look, right, what's there, you do some analysis, like is there something missing, you know, like what are the statistics depending on the data that you're using, you know, like you can identify is there something missing, you know, or basically are there any patterns that you can spot, you know. This is all, I mean, machine learning is all about spotting some patterns and training algorithms to actually learn those patterns that we can apply later, right? So this phase is like, let's understand the data, get our intuition, and based on this intuition, we will build models which will, you know, like represent that intuition. So the next phase is actually modeling, and that is when you're, you know, like you're testing different hypotheses. You say, okay, I think this will work, you know, like this can predict, let's say, that the next transformation would be that, right? Based on this, right? And this is a hypothesis. And until we don't try it on the real data, it's just a guess, right? I mean, we can think it's working, but until we don't put ship into water, we don't know is it going to float, right? So it's the same here. So we have some idea, and then we test it on the data, right? And here the rule of thumb is try first the most simplest idea that you have. I mean, the reason is very simple, because first you won't spend a lot of time, you know, implementing that. And the second one is, if you have to throw it away, you won't be very sorry, right? I mean, if you spend weeks or even months developing some very complex model, and then you realize that it's not working, it's not great, right? But if you can rapidly prototype, spend maybe half a day or a day developing something, and then you try it as soon as you can, you can get some, you know, like you can learn something from there, you can get some feedback, and then you can, you know, like improve it and add more complexity as needed. So this is the cycle. Basically, you know,
Sorry,
like,
Bojan, there's a couple of questions just come in there. Sorry to disrupt your flow.
Sure.
Just two questions have come in. A lot of these functions in ETL seem similar to a SQL workflow or query. Are they entirely different functions?
So those ETLs, like you can have a stored procedure as a part of, you know, like as one of the transformations. The whole thing here is that you don't need to write a lot of code. So, you know, like you visually can see how the data is flowing and rely on the abstractions that transformations are providing for you. So basically the transformations are you know, like these are the common things that a lot of people are using. And instead of, you know, like writing your own SQL, Java, or whatever code, you can just, you know, like drag and drop that on the canvas and use it.
Okay, perfect. And then second question, 70–80% of time spent in data acquisition. Does this mean that all the data and data cleanup is spent in the data acquisition phase, or is data exploration has no change of the data?
Yeah, that's a great question, actually. You know, like these phases look like it's a, you know, like there is a step-by-step things, but it's not like that, right? I mean, like a lot of these you have back and forth, and basically when you do, you know, like you get some data, you transform it in a way you think you can, you know, like easily use it. Then you figure out, oh, okay, when you start exploring it, oh, I'm missing something. So you go back, right? And then you change something. So, you know, like it's not kind of, you have a fixed steps that you follow. It's more, you know, like you as you progress, you you know, like transform your data as you like, and then basically you I would say that the main thing is that you get an intuition of, you know, like what's there in the data and what you're developing, and then accordingly, you know, like you change. For instance, like let's say, you know, like we've been looking at in the transformation that is before, right? The transformation that we're predicting, but then we realized, oh, look, maybe we can, you know, like look not just one before, we can look two before, right? And then we change, you know, like how we're transforming data that we can, you know, like set up, right, for this what we want. So that's the part, right? I mean, like usually you start this with something as simple as possible, and that you can go through the whole cycle as fast as possible, and then you learn, right? And
just like a normal workflow, it's going to ebb and flow with if the next stage is hit, great, move on to the next stage. If not, regress back to where you were.
Exactly, right? I mean, our goal is to have exit here, right? When we are on deployment, and that we can go to production, and, you know, like whatever comes us, you know, like faster to this one, basically we focus on that. So my point is, like, you know, like spending a lot of time on things that you're not completely sure that you're going to use, right? It's not a great idea. Usually, you know, like let's see how we can go as fast as possible to this phase, and then we can decide, right? I mean, do we need to change something?
That should answer Paul's question around you know, there around the normalization. Just the other question, last one, and then we'll keep going. Extract might also be taking data from unstructured sources and not necessarily existing databases. Is this right?
So the question is, how can we extract the data from unstructured sources, right? Or non-existing databases? Yeah. Is that?
Well, no, it might also come from an unstructured source rather than your, you know, your existing database. Is that right?
Ah, okay. Okay. So the question is about the ETL procedures, right?
Yeah. I'm guessing
okay.
So.
Yeah. Okay. So for the unstructured, I assume it's about the text. So you can process the text and do some parsing on the text, right? I mean, to the best of my knowledge, how you know, like people are using ETLs, is mainly for the structured ones, but also you can, you know, like parse some hierarchical data or unstructured. I know there was some there was some support, for instance, from text extracting like named entities, right, and then connecting them. Like named entities are persons, organizations, and that stuff that are mentioned in text. So you can mix a lot of things, you know, like it gives you an abstraction, and you know, like this is what for ETL procedures you can use, you know, like to save you some time, right, that you can progress faster. All right, so I was talking about the modeling phase, right, and the next phase is actually evaluation, and evaluation is where you're testing your hypothesis, right? Here you put it something that is, you know, like that is solving your task, and then actually you're evaluating how well it is solving that task, right? I'll talk in more details about that one, and this is an important phase of the whole project, because, you know, like how well you evaluate the different approaches, that is based what you will put into production. And like there are a lot of different evaluation methods, as well as different algorithms and you know, like what you and libraries that you can use for developing machine learning models. And then when you're right, I mean, here you can go forward if you're happy with the results, or as I said, you can go backwards, and, you know, like if you're not getting results as you would like, basically you go back to some of those, like either modeling, or you want to explore a little bit more data and understand what's there, or you need to get some more data or transform in a different way, right? And then we have a deployment where actually we put our model into production, and, you know, like the rest of the system can use this model to make some predictions, actually to get the results from the model, right? So this is the general life cycle, and here is the first phase that we had about the actually data acquisition. So what we had, we had like mappings metadata, right? And actually we had metadata from two products. So one product is Power Center, which is the on-prem product. So you can install it on your machine and develop those ETL procedures. And the second one is the cloud data integration, where we were able to get the anonymized data from some repositories, and actually you use that data for training our models. And the thing was here that formats were not completely compatible. There were some differences. So we developed a pipeline for actually bringing those two models to a canonical or a unified model. So here you can see, like, we have the data from cloud data integration, we have from Power Center, right? And then we translate and parse into a unified model that we can visualize, right? And then build on top of that our models. So here is an example of the mapping graph, how it looks after we, you know, like convert it to a unified model. So basically here you have nodes and you have edges, right? So it's a graph, right? Which connects different transformations. So here we have a source, here we have another source, then there is a sorter, then those two sources are joined, and etc. And then at the end you have a target where you're storing your records, right? That you transformed. So I would like to share also about the data timeline, and this is something typical for the machine learning projects. When you know, like when you do some course on Coursera or, you know, like on internet, you have prepared data and, you know, like data set, and you focus on algorithms and, you know, like how those things are working. And you usually, you know, like in production, in industry, as you're developing your project, you're also getting the data, and that's a reality, you know, like, and it's very important step, because the you know, like the better data you secure, right? I mean, there is higher likelihood that your project will be successful, because probably, or maybe you heard about that expression, garbage in, garbage out, right? I mean, if you put some low quality data into your model, I mean, you train it on that, it cannot learn better than the data that you provided. So basically, it's very high chance that the results won't be very good. So this is an important piece of the project, where you're securing your data. And here you can see the timeline for this project. So actually, we have a specific timeline for developing all projects. And so you have an initial phase when you start, and, you know, like you're doing your POCs, your proof of concepts, and then you have a feature freeze. And the feature freeze is a hard deadline when you have to stop with everything, with all your development. And that is because, you know, like what you developed, you can, that's what you can put into production, because then other teams start to, you know, like test the quality of what you have developed, how it's, you know, like both functional and non-functional, like how it's scaling and all other stuff, right? So to leave time for them, basically we had a deadline where we had to stop, you know, like, and not to develop further the feature, right? So this is the timeline. It was a little bit more than 3 months. So for this particular project, three months, you know, like it's kind of very tight, you know, like for every project, 3 months are tight, but especially for machine learning and data science projects, this is, you know, like it's very short time frame, and it's required to act very quickly, you know, like that you can basically put your things into production. So what we had initially, we had some internal data. So we had one Power Center repository with a little bit less than 700 mappings. And also we had internal cloud repositories that had a little bit more than 800 mappings in total. And those were from 3 orgs. So think about the orgs, organizations, right? These are the domains that are independent, and that they're using, you know, they're building their own mappings inside, right? So some client can have only single org, right? Or some client can have multiple orgs. For instance, like usually if it's geographically distributed, you can have one org for EMEA, another org for US, etc., right? So this is what we started, and it was a very small amount of data. The good thing was we were able to start, you know, like building the pipelines and you know, like understanding the data and all that data exploration piece. And in parallel, the other team that we've been working closely was actually working on a project to enable us the access to, you know, like real data that and significant amount of data. So they've been building, you know, the system that actually, you know, like takes the data, anonymizes that in secure zone, you know, like, and then we get the completely anonymized data. I mean, this is right from the legal perspective and from all other, we don't see actually, you know, like what's there, what is the metadata, what is the, we just get those graphs, you know, like that was the important thing for us, right? And so the team was building in parallel that system to enable us the data. So a month before, we got a replica of the system with significantly larger number of mappings, like almost 6,000 mappings and from 51 org, right? And then 3 days before, we were able to access the production data, which had like 147 orgs, and in total, like it was a little bit less than 50,000 mappings, which was a way significantly larger number of the mappings. So at the end, we trained our models on this significantly larger data. And in the meantime, we were using, you know, like the smaller repositories to test some ideas and you know, like see actually what's working and what is not working. And obviously, there were like two challenges. First one is time. And here, how you know, how to quickly produce models with new data. Basically, we knew, you know, like, because data was not available at the beginning, you know, we knew we won't have a lot of time to tune, you know, like some very complex models, because, you know, like you can use some very heavy machinery, but it takes time to tune that and to work, you know, like on some you know, like specific data sets. The second challenge was data availability. Basically, from the start, we knew we won't have all the data from all our customers. So at that time, like we had around 6,000 orgs, and we knew we will have an access only to 147 orgs, because this was a new project, and the idea, you know, like basically there was no mechanism for our users to opt in and, you know, like allow us to use their data. But basically the PM, you know, contacted each of those 147 orgs, and they, you know, like allowed us to use their data and train the models. And this is also something, you know, like it's a typical thing, right? It's a chicken and egg, right? Like you know, like if you want to ask your users to train models on their data, right? You need to show them that they can get the value from there, right? So you need to develop something that can work in production. And then, you know, like if they are willing to contribute, basically you can use their data and improve your models further. So it's kind of, you know, like basically we develop some feature, and then as we go, right, and as we are acquiring more data, we improve it and you know, like add more accuracy. So here the challenge was how to capture general patterns, right? I mean, because we knew we're looking only on 2% of the data, how, you know, like we capture the general patterns for the 98%, right, of other customers that are going to use, right, I mean, this feature. So these were two main challenges that shaped, you know, how we approach the whole project. And so we started with data exploration, right? And the first question for us was like, is there a pattern in data? And can we, you know, like actually, can we learn something from the data? So what we did, we developed a Cooccurrence Matrix. And here you can see like a row represents current transformation and column represents next transformation, right? So we wanted to see if we know the current transformation, can we predict what is next, right? It's a very simple model. And here you can see, hopefully you can see some tiny numbers. Here is a part of this Cooccurrence matrix for one data set. So basically here we counted, you know, like, for instance, like how many times after sorter, which is one transformation, we can have an aggregator, right? And this is the number. And this matrix is also color coded. So you can see that the darker colors mean there is a more frequent pattern, and the lighter colors mean there is no, right, that pattern, there is no co-occurrence. So here you can see that there are some patterns, right, that we were able to spot. For instance, like after stored procedure, there is an expression which, you know, like there is a high correlation between those two. And for some others, right, there were kind of not very frequent patterns. So what we did, basically, we developed quickly a model that can, you know, like capture these patterns. And this is we call it frequency-based model. And it's a very simple model where K is the number of recommended transformations. So basically with number K, we define how many recommendations we want to provide to our users. And so here is an example, right? Let's say, let's imagine we have just 4 transformations. In reality, there are much more. And we have like expression, filter, joiner, and lookup, right? And this is like the current transformation, and the columns mean the next one, right? So what we can do, we can calculate those frequencies, right? How frequently after this, let's say after filter, there is an expression transformation. So if K is equal to, and we have, let's say, a filter transformation as the current transformation, then we can, you know, like basically query this table and find the most frequent ones that are, you know, like that are following this transformation. So let's say in this example, like it's an expression and it's a lookup where we, you know, like also we can have an guess about how what the accuracy we will have. Like if we sum those two frequencies, basically we can guess that it's around 80%, right? In 80% of the cases, we will have those two transformations following the filter. And this is the first model that we implemented and evaluated, right? We wanted to see how it works, right, with the simple model, and how can we iterate and improve further. So for this, we use the evaluation metric for evaluating recommendations. And in recommendation systems, there is one popular metric, which is precision at K. And it gives you an estimate how well you're recommending something to the users based on the number of hits and misses, right? And hits, in our case, is the number of occurrences of next transformation from original mapping in the top K recommendation. So, right, we take one of the mappings from our data set, and basically, you know, like we get the pairs, right? What is following what, and we train our model. We calculate the frequencies, but then we use the subset of this that, you know, like another part of the data set actually to estimate to evaluate how well the recommendations are doing. And for this case, basically we're looking if we have a particular transformation, what transformation we are recommending, and is within those transformations that we are recommending actually the recommendation of the transformation that is used in the mapping, right? So the thing is, right, we are pretending, right, that we don't know which transformation was following, right, the current transformation, and we recommend some transformations, and then we look to match is within those that we recommended, is there a actual transformation that was used, right? So this is the intuition behind this metric. And for the misses, like for the number of the occurrences where we didn't predict, right? Next transformation from the original mapping, this is, we counted that as a miss, right? Because there was no the original transformation that is in the mapping. And this is the formula that is calculating this metric. Okay, so these are the results on initial data set, and we were varying the number of K, basically, where we like if we show only one recommendation, what is the precision, right? And in this case, it was around 40%, right? And if K is 3, right, then if we show 3 recommendations, then of course we have a higher chance to actually recommend the one that is in the original mapping. And here the precision was around 72%, right? And if we show 5, right, then the precision went up almost to 84%. And we showed this to our PM, to product manager, and to UX, and they recommended to us to show the first 3 recommendations. So, like if we show a lot of recommendations, it's not well, right? If we show only one, again, the user is not able to choose from those. So we selected the K parameter, the number of recommendations, as 3. And we are showing, like in this feature, basically we're recommending 3 transformations that can be used on the canvas.
Sorry, Bojan, I'm just going to give you a 5-minute warning.
All right. Okay. Okay. I'll go faster. Yeah. The next thing is I won't stick to the too much to the technical details, because it's lunchtime, and I assume with like it's not easy to digest both things, right? I mean, a lot of technical things and and food. So okay,
there was just one question that that popped in around the product manager. Just find it here now. It was around the value of this process to a product manager, and how probably not for this session, but I'm interested in hearing why the product manager of the CTL tool felt it was worth investing in this product or project. What value or impact did they get from it?
I see. What's the value for the users, right? Yeah, that's a good question. Well, the value is basically we want to enable users to progress as fast as possible, right? I mean, instead of looking and like searching in the list of the transformations, basically they can like pick from the list of our recommendations and like select those. So that was the main value. The second value was some like best practices, and like some frequent patterns that we are using like to build those mappings. So that was the second value for the PM. Okay, so all right, so we used, right, I mean, frequency-based model, like the first order model to recommend these transformations. And then we were thinking, okay, what if we just not look at the one before? Basically, we also look like 2 following transformations. So what is like before the current transformation, what are the transformations also used? Can this improve the model? And this is what we named the second order model, right? So this is the first order model. We're just looking at the current transformation, and we predict what is the next transformation. And also, like we're in the second order model, we are using also the transformations that are before this current transformation, right? And in our experiments, this increased precision by 13% for a precision at 1 for the top right recommendation, and precision at 3 by 9%, right? So I mean, we use this as a set of features. And the second thing that we identified is basically that there are two patterns, two most frequent patterns, how people are using, how they are building the mappings. And one is like, like people start from the left to the right, right? And they, put source, and then they are adding transformations. And in the end, they add the target where they want to store the results, right? And this is what we call leaf recommendation, because we know what is, what are the transformations before, but we don't know what is following. And another pattern is like we, some guys put the source and the target, and then they start adding transformations in the middle. Like they're basically like, you can, like when you're writing your function, right? You can put your code, first put the algorithm and then interfaces, or you can put interfaces and then, like you can write your logic. So these were like two patterns. And actually we developed two models to cater for those two patterns. And this is in our experiments, we got increase in precision at 1 by using these two models. Okay, so when we were done with our POC, basically then there was a step to move to production. And here there were two challenges. Like first one, the tech stack was Java based, and our POCs were developed in Python. And we've been using some, like some popular machine learning libraries like scikit-learn to train models. And also there was a response time requirement. So to have a responsive UI, we needed to make predictions in certain amount of time, right? So basically what we did, we investigated what are the options, right, to move our POC to Java production code. And I'll briefly go through all different options. So one option is to embed. Basically, you have two code bases, and you have Python and Java code, and then like you can run your model and query for the results. The cons of these approaches, you have additional glue code, and there is a communication overhead. And also you have to maintain two code bases, which is not great. The second thing which is available is like you can transpile your models or transcompile your models to Java. And there are some libraries where, like you can put as an input your scikit-learn model, and they generate the Java code that actually, is behaving in the same way as the model. The cons here were, like it's the quality is not always the same, and there is a limited number of supported models. And the third option that we actually took is to redevelop our models using some of the libraries that support both Java and Python. And in this case, we used Spark, which is widely, like used in Informatica, and basically here we had the, like we got the speed and also the scaling, right? And the nice thing was that the code for training stayed in Python, so we were able to train our models in Python, and we converted the code for making actually predictions for, for generating recommendations. We re-implemented in Java. And this is the path we took. Basically, there is no single solution that fits, like all use cases. So depending what you, like depending from your requirements, these are some of the options that you can consider.
It's coming close to 2, Bojan. Do you want to?
Yeah, I'll
give your wrap up.
Yeah, I'll wrap up. These are the production results we got. So basically, it got released in summer 2019, so the previous year. And so far, the acceptance rate for these models is 60%. So out of all recommendations that we provide, our users are accepting 60% of them. And with a small variation of plus minus 5% or different months and different pods. They're pod like for US, right, EMEA and that. So this is the acceptance rate. Like it's almost like 2 out of 3 recommendations are accepted. And I provided here a link for a trial if you're interested, like to get your hands on and try all the things that I talk about, not just, like the recommendation part, but also the data integration, right? Okay, and yeah, about the future work, I'll just keep that. I just want to thank the whole team, and this is the like the teams that were involved in this product. Many teams like Core AI that I'm part of, then the product team, right, the platform that helped us to develop the microservice, then PM and user experience, quality assurance that like tested, legal that like made sure that we are compliant to all the.
I'm gonna have to cut you, but
and okay.
Probably the easiest. There's a couple of questions that's come in. It's just hit 2, and people have to get back. If you don't mind, can people reach out to you directly on LinkedIn?
Yeah, yeah, sure. I mean, feel free to reach and we can like follow up.
But no, thanks, Mil, for your time, Bojan. It was really interesting to learn. I'll send around the video so people have for themselves that attended, and your LinkedIn profile if anybody has any questions directly. Please do reach out. We'll be having another lunch and learn in the next week or 2, and there's a couple of more things coming through. So thanks, Mil, for everybody turning up. Thanks, Bojan, for speaking, Informatica for letting you, and for Icon Accounting for always sponsoring our events and stuff like that. Good seeing everybody, and any questions, Bojan, reach out. Any questions for Dublin Tech Talks, reach out as well. Speak soon.
All right. Thanks, everyone.
Thanks, everybody.